Hello students and friends, we were going through the chapter electricity and this is the fourth lecture. So here in this lecture we shall discuss resistors connected in series and resistors connected in parallel. In the previous video segment we did discuss Ohm's law and we also observed the relationship between voltage and current, and we also defined what is resistance and resistivity. The next question which comes to our mind is what happens if resistors are connected in series and what happens if resistors are connected in parallel. Now let us consider this circuit diagram. So here there is a battery of voltage V plus minus connected in series. So there is a battery of voltage V and we have three resistors connected in series, R1, R2 and R3. Now when resistors are connected in series, we observe that the current I flows through R1, the same current I flows through R2 and the same current I flows through R3. Now you may get a question. When current flows through the ammeter, ideally there is no voltage drop. So therefore the entire voltage V appears across the 2 points X and Y. The other question which may arise is, the current I, will it get diverted and will it flow through the voltmeter? I have a voltmeter connected. So no current flows through the voltmeter because the voltmeter ideally has very high resistance or infinitely high resistance. So all that you need to remember is the drop across the ammeter is 0 and no current flows through the voltmeter. Hence, the current I will flow through R1, the same current I will flow through R2 and the same current I will flow through R3. So therefore, we know that the relationship between voltage and current is V equals I into R. So in that case, so we have current I which flows through R1. So I is flowing. So therefore, the voltage across R1 is V1. The voltage across R2 is V2 and the voltage across R3 is V3. So therefore, we observe that V1 equals I into R1. V2 equals I into R2 and V3 equals I into R3. And therefore what do we observe? We know that V equals I into R. So therefore let me add all the three voltages, V1 plus V2 plus V3. It is IR1 plus IR2 plus IR3. So if I take I common, I get R1 plus R2 plus R3, and we know that the voltage V is nothing but V1 plus V2 plus V3. So therefore V equals I into, so let me call this as R equivalent. So therefore if three resistors are connected in series, then the equivalent resistance is equal to R1 plus R2 plus R3. So what do I mean by this? It means that I can replace all these three resistors by a single resistor whose resistance is equal to the sum of the individual resistors. So if this is 100 ohms and this is 100 and this is 100, I can replace all these three resistors by a single resistor having an equivalent resistance of 100 plus 100 plus 100 equal to 300 ohms. Right? So this is what happens when resistors are connected in series. Now the question is, what happens if two resistors are connected? Then the equivalent resistance would be R1 plus R2. If there are 10 resistors connected, it would be R1 plus R2 plus R3 and so on up to R10. So in general, the equivalent resistance, so it is the series equivalent resistance, so we are talking about series, is nothing but R1 plus R2 plus so on up to Rn. So if there are n resistors connected, it will be the sum of all of them, right? So this is what happens when resistors are connected in series. So the statement is, when several resistors are joined in series, the resistance of the combination Rs, so this is called as Rs, which is the series equivalent resistance, is the sum of the individual resistances. So therefore, the series equivalent resistance is greater than any one of the resistors. So let's take a problem. Example 12.7, which states that a lamp with resistance 20 ohm and a conductor of resistance 4 ohm are connected to 6 volts. So they are actually connected to 6 volts. So there's a diagram there. So we have a 6 volts supply, and then we have an ammeter, and then you have a switch. There is a resistor of resistance 4 ohms, and then there is a lamp connected in series. So it's been stated that the resistance of the lamp is 20 ohms. So these two are connected in series, right? So now let the current flowing through this circuit be equal to I. So the question is, find the total resistance. So what is the total resistance? The total resistance R is nothing but, this is R1, this is R2. So it is R1 plus R2, which is 4 plus 20 equal to 24 ohms. Very simple. What is the potential difference across the lamp and across the conductor? So therefore, let the potential difference across R1 be V1, across the lamp be V2. Right? So we know that V1 equals I1 into R1. So given by the expression here. So therefore I need to find the current. So what is current I? It is nothing but V by RS. The total resistance, we have to remember that. It is 6 by 24, which is 0.25 amperes. Do not forget the units. So therefore V1 is across the conductor. V1 is nothing but 0.25, which is the current, into 4. So it is equal to 1 volt. So this is the voltage across the conductor. And what is the voltage across the lamp? It is 0.25 into 20. So I get the value as 5 volts. So this is example 12.7. So now we have a few questions. Question 1. Draw a schematic of a circuit of a battery of 3 cells of 2 volts each. So there are 3 cells of 2 volts each. And we have resistors 5 ohm, 8 ohm and 12 ohm and a plug key, all of them connected in series. So there are 3 cells. So let the 3 cells be connected in this way. One cell, the second cell and the third cell. So this is plus minus 2 volts, plus minus 2 volts, plus minus 2 volts, right? And then I have 3 resistors, 1, 2 and 3. So this is 5 ohms, 8 and 12 ohms. And therefore you also have a plug key or a switch which is connected. And how does the current flow? The current flows from positive to negative. So current I is flowing in this direction. The second question states that redraw the above and put an ammeter to measure the current. So I need to put an ammeter to measure the current and a voltmeter to measure the potential difference across 12 ohms. What would be the readings in the ammeter and in the voltmeter? So let me make a slight adjustment here. So I need to measure the ammeter. So if you want to measure the current, the ammeter has to be connected in series. So I connect an ammeter here. So an ammeter is connected. So current is flowing in this way. So this is plus minus. And then there is a voltmeter which is connected across 12 ohms resistor. So this is a voltmeter. Current is flowing. So this is plus and this is minus. Alright. So now the question is, what would be the readings in the ammeter? So I need to find the current. So what is the current? The current I is V by R. S, series resistance. So therefore, what is the total voltage? Voltage is 2 plus 2 plus 2, which is 6. And what is the series resistance? 5 plus 8 plus 12. Very simple. It is 25. So the total current would be 0.24 amperes. So this is the current. So next I need to find the voltage. So what is voltage across 12 ohms? It is I into R, which is 12. So it would be 0.24 into 12. So what is 0.24 into 12? You get 2.88 volts. So the voltmeter would read 2.88 volts. So this is what happens when resistors are connected in series. So now what happens if resistors are connected in parallel? What would happen? We shall see that. So what happens when resistors are connected in parallel? So let us consider this circuit here where three resistors are connected in parallel. So there is R1, R2 and R3. So what we observe is that the voltage across R1, R2 and R3 remains the same. But what happens to the current? So we observe that this current I will divide. So you have current, say I1 flowing through R1, another current, say I2 flowing through R2, and another current I3 flowing through R3. So the voltage remains the same, but what happens to the current? The current flowing through the resistors will vary. Now we know that V equals I into R. Alright, this is the general expression, but here what happens? V equals I1 into R1. Similarly, V equals I2 into R2 and V equals I3 into R3. And what is constant? Voltage is constant across all the three resistors R1, R2 and R3. Alright, so now we know that I1 equals V by R1. So I'm just trying to find the currents. I2 equals V by R2 and I3 equals V by R3. And I know that current I is the sum of all the three currents flowing through the three resistors. So it is I1 plus I2 plus I3. Right? So therefore, I have I is nothing but V by R, which is I1. What is I1? V by R1. Plus what is I2? V by R2. And what is I3? V by R3. So let me take V common. I get 1 by R1 plus 1 by R2 plus 1 by R3. So I have V by R equals V into 1 by R1 plus 1 by R2 plus 1 by R3. V and V gets cancelled. So therefore 1 by R equals 1 by R1 plus 1 by R2 plus 1 by R3. And what is this R? This R is nothing but the parallel resistance. So let me call this as RP. So the reciprocal of the equivalent resistance of a group of resistors which are connected in parallel is equal to the sum of the reciprocals of the individual resistors. So if resistors are connected in parallel, what is the equivalent resistance? You take the sum of the reciprocals of the individual resistances, and that would be equal to the reciprocal of the equivalent parallel resistance. So this is the expression which you need to remember. So now let's solve the exercise problems. So we have example 12.8, and what does it state? There is R1 which is equal to 5 ohms, R2 equal to 10 ohms and R3 equal to 30, and they are all connected to a battery of 12 volts. So we need to find A, the current through each resistor, B, the total current, and C, the total resistance. So they are all connected in parallel. So I have R1, then you have R2, and then you have R3. All the three resistors connected in parallel. So 5, 10 and 30 connected across 12 volts, so this is plus minus. So this is the total current I, and I have I1, I2 and I have I3. So now the question is, I need to find I1, I2 and I3. So what is I1? I1 is V by R1, which is 12 by 5. So what is 12 by 5? 12 by 5 is 2.4 amperes. Next, what is I2? V by R2, which is again 12 by 10, which is 1.2 amperes. Right? So it's very simple. Next, I3 equals V by R3, which is 12 by 30. So you get it as 0.4 amperes. So this is the first part where I need to find all the individual currents, that is the currents flowing through each of these resistors. Next, part B, the total current. What is the total current? The total current is nothing but I1 plus I2 plus I3. So I need to add all the three currents to get the total current. So I would end up getting a value which is 2.4 plus 1.2 plus 0.4. So that would give me a value of 4 amperes. So this is the total current. Next, I need to find the total resistance. So which is nothing but RP, the parallel resistance. So we know that by this expression, 1 by Rp equals 1 by R1. So what is R1? 1 by 5 plus R2 is 1 by 10 plus R3 is 1 by 30. So I need to find the sum of all these three resistors. So let me take LCM. If I take 30, so I get 6 on top, right? Because 5 by 30 is 6 plus 30 by 10 is 3, 30 by 30 is 1. So 6 plus 3 plus 1 is 1 by Rp. So this is 10 by 30. So 10 by 30 is 1 by 3. So 1 by Rp is 1 by 3. What is Rp? You take the reciprocal, it is equal to 3 ohms. So this is the equivalent parallel resistance of all these three resistors, of course connected in parallel. So there is a circuit given where R1 equals 10 ohms, R2 equals 40, and then we have R3 equals 30 ohms, and then we have R4 which is equal to 20, R4 equals 20 and R5 equals 60, and the battery is of course 12 volts. So now the question is, I need to find the total resistance and also the total current. So how do I find the total resistance? Of course, first I need to find the equivalent resistance. So we observe that here these two resistors are connected in parallel and these three are connected in parallel. So let me call this as R dash and let me call this as R double dash. So we know that 1 by R dash is 1 by R1 which is 1 by 10 plus 1 by R2 which is 1 by 40. Alright, so what do we get? So this is 40, 4 plus 1 which is 5 by 40. Or what is R dash? It is 40 by 5. So what is 40 by 5? It is 8 ohms. So I can replace this by R dash which is 8 ohms. Next, I have 1 by R double dash which is equal to 1 by R3 which is 1 by 30 plus 1 by R4 which is 1 by 20 plus 1 by R5 which is 1 by 60. So let me take LCM 60. 60 by 30 is 2. So I have 2 here. Plus 60 by 20 is 3 plus 1. So it is 6 by 60 or it is 1 by 10. So what is R double dash? Is reciprocal of 1 by 10 which is 10 ohms. So now how do I modify this circuit? So this circuit can be modified as R dash, which is 8 ohms, and then you have R double dash, which is 10 ohms. Both of them are connected in series, isn't it? So you have plus minus 12 ohms. Of course, you have an ammeter connected here in series. So now these two resistors are connected in series. So therefore, our total is R dash plus R double dash, which is 8 plus 10, which is 18 ohms. And what is the total current? The total current I total is V by R total, which is 12 by 18. So 12 by 18, we get it as 0.667 amperes. So this is the total current which is flowing in the given circuit. So let's go through the questions given at the end of this section. Judge the equivalent resistances when the following are connected in parallel. The first one, 1 ohm and 10 power 6 ohms. So since the resistors are connected in parallel, I have 1 by Rp is 1 by 1 plus 1 by 10 power 6. So you get a value of 1 plus 10 power 6 by 10 power 6. So if I take the reciprocal, Rp is 10 power 6 divided by 1 plus 10 power 6, which is approximately equal to 1 ohm. Right? So 10 power 6 plus 1 is almost the same, so it is equivalent to 1. Next, B, if I have 1, 10 power 3 and 10 power 6 which are connected in parallel. So I have 1 by Rp, which is 1, plus 1 by 10 power 3 plus 1 by 10 power 6. So here what happens? If I take 10 power 6, I get 10 power 6 plus 10 power 6 divided by 10 power 3 is 10 power 3. 10 power 6 by 10 power 6 is 1, so I get 1. So this would give me 1 by Rp is 10 power 6 plus 10 power 3 plus 1. So I have 1, 0, 0, 1, 0, 0, 1. Right? This is 10 power 3, this is 10 power 6 plus 1 divided by 10 power 6. So Rp is 10 power 6 divided by 1001001. So what will I get? So I'll get a value which is approximately equal to 0.999 ohm, or it's approximately equal to 1 ohm. So we must remember that if resistors are connected in parallel, then the equivalent parallel resistance will always be smaller than the smallest resistance. So this is the conclusion what we make. An electric lamp of 100 ohms, a toaster of resistance 50 and a water filter of resistance 500 are all connected in parallel to a 220 volts. So this is what I have drawn here. The circuit, this is the resistance of the electric lamp, 50 is the resistance of the toaster and 500 is the resistance of a water filter. What is the resistance of the electric iron connected to the same source, taking as much current as all the 3 amperes, and what is the current in the electric iron? So now the question is, what is the resistance of the electric iron connected to the same source, taking the same current? So now these 3 are connected in parallel. So the question is, what is the current here? First, let's try to find the current drawn by all these 3 devices which are connected in parallel. So now I have 1 by Rp, which is 1 by 100 plus 1 by 50 plus 1 by 500. So I have 500 here, 5 plus 10 plus 1. So I get 16 by 500. Or what is Rp? Rp is nothing but 500 by 16. I get it as 31.25 ohm. So now let us find the current. What is the current? The current is 220 divided by 31.25, which is 7.04 amperes. So this is the total current drawn when all these three devices are connected. So now, instead of these three devices, what are we doing? We are removing these three devices and connecting 220 volts to a single device. And what is that device? That device is an iron, an electric iron. And the question states that it draws the same current, which is 7.04 amperes. So if this single device draws the same current as these three devices connected in parallel, then the resistance of the electric iron is 31.25 ohms. Why? Because it is drawing the same current and the source is 220 volts. So therefore, the resistance of the electric iron resistance R is equal to 31.25 ohms. So the third question, what is the advantage of connecting electric devices in parallel with the battery instead of connecting them in series? So we know that if I have two or more devices which are connected in parallel, and if I have voltage V, then the voltage across each device is going to be V. So what is the advantage? The advantage is there is no division of voltage. So no division of voltage. No division of voltage means I get the same voltage across each and every device, and also the parallel connection. What happens if all the devices are connected in parallel? When the devices are connected in parallel, their equivalent resistance reduces. So therefore, when they are connected in parallel, the equivalent resistance reduces. So this is very important. Fourth one, how can 2 ohm, 3 and 6 ohm be connected to give an equivalent resistance of 4 and to give an equivalent resistance of 1? Part B is very simple. I need to get 1. That means all the three have to be connected in parallel, isn't it? So if I have 2, 3 and 6 connected in parallel, so what is 1 by Rp? It is 1 by 2 plus 1 by 3 plus 1 by 6. So if I take 6 as the LCM, 6 by 2 is 3, 6 by 3 is 2 plus 1, I get 6 by 6, which is 1. So Rp is 1 by 1, which is 1 ohm. So this is part B, answer for part B. Then A, I need to get a resistance of 4 ohms. So if I need to get a resistance of 4 ohms, what should be done? Let's do trial and error. Let me connect 6 and 3 in parallel. So I connect 6 and 3 in parallel, and then I have 2. So 6 and 3 in parallel, what is the equivalent resistance? So 1 by 6 plus 1 by 3 is 6, 1 plus 2, which is 3 by 6, which is 1 by 2. So therefore, if I call this as R dash, the equivalent resistance, R dash is reciprocal of 1 by 2, which is 2. So this is 2, so R dash is 2 plus another 2 ohms connected in series. So this is 2. So 2 plus 2 will give me 4. So R dash plus 2, which gives me 4 ohms. So to get an equivalent resistance of 4 ohms, I have to connect 6 and 3 in parallel and then 2 in series, so I get 4 ohms. Next, fifth one, what is A, the highest, B, the lowest resistance R if 4, 8, 12 and 24 resistors are connected. So what is the highest? I have to connect all the resistors in series. So when I connect all these 4 resistors in series, what is the total resistance? It is 4 plus 8 plus 12 plus 24. So I add all of them, I get 48 ohms. So if I need to get the highest resistance, so if I have 2, 3 or more resistors in a circuit, and if I have to get the highest resistance, what has to be done? They just have to be connected in series. But if I need to get the lowest, they all have to be connected in parallel. So therefore 1 by Rp is 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. So take 24. So 24 by 4 is 6. 24 by 8 is 3. 24 by 12 is 2. 24 by 24 is 1. So add them. 6 plus 3 plus 2 plus 1. 9, 10, 11, 12. So I get 12 by 24, which is 1 by 2. So what is Rp? Reciprocal of 1 by 2, which is 2 ohms. So you observe that if all these 4 resistors are connected in parallel, the equivalent resistance is 2 ohms, so it is lower than the smallest resistance, which happens to be 4 ohms. So in this video segment, we have gone through what happens if resistors are connected in series and what happens if resistors are connected in parallel, and we've gone through all the worked examples and also have discussed the questions given at the end of the section. I hope you have found the lecture informative. Do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and click on the I icon to view all the other videos in science for 10th, and also go through the playlist Mathematics for 10th standard. And thanks for watching.